Assalamualaikum warahmatullahi wabarakatuh. Today we're going to discuss and explain about the answer of BEKC2453 assignment, Communication System. We've created a group of 5 for this assignment, and among of the group members we have me, myself, Muhammad Syafiq Izzuan bin Abdul Rashid. Second groupmate is Muhammad Zainul Hakim bin Azahar. Third, we have Muhammad Shahir bin Sabri. And for the fourth groupmate is Muhammad Ashraf bin Khairul Nizam. And lastly, we have Muhammad Ilman Ilhami bin Marzuki. Without further ado, let's get into it.
Assalamualaikum, my name is Muhammad Zainul Hakim Azhar, and today I want to talk about the question 1 in the group assignment. For the question 1, as for each of the following 4 network, discuss the consequence if a connection fails. A. 5 devices arranged in a mesh topology. B. 5 devices arranged in a star topology in bracket not counting the hub. C. 5 devices arranged in a bus topology. D. 5 devices arranged in a ring topology. The arrangement of the various parts of a communication network is known as network topology. There are 4 different types of network topologies, which is mesh topology, star topology, bus topology, ring topology. Okay, now as you can see, this is the example of the mesh topology. A mesh topology, every device has a dedicated, reliable point-to-point connectivity with every other device. If a single connection fails, the system as a whole is not rendered unusable. So, even if one link or device fails, the other continue to function or still be working. Okay, for the question B, this is the star topology. A star topology, it is a network topology in which all other nodes are linked to a central node, such as a switch or hub. As it is specific to exempt the hub, if any other node fails, the network will not be affected because the hub or switch is operational. Therefore, if a link breaks in a star topology, it will not affect the entire network because the remaining nodes will continue to function or still working. Okay, for the question C, we will discuss about the bus topology. Okay, this, as you can see, this is the bus topology. A bus topology is a multi-point connection. Nodes are connected to the bus cable by drop lines and tabs. A drop line is a connection running between the device and the main cable. If the drop line fails, only the corresponding device cannot operate. Therefore, all transmission is halted if one of the bus cable connection breaks. Last but not least, for the question D, it's about ring topology. For the ring topology, each device has a dedicated point-to-point connection with just 2 devices on either end. A signal is transferred from device to device along the ring in one direction until it reaches its destination. Other than that, unidirectional traffic, on the other hand, might be a disadvantage. So, if a connection in the ring breaks or fails, the entire network is disabled, unless it is a dual ring or a switch capable of sealing off the break. That's all from me for question number 1. I will pass to next presenter to answer the next question.
Assalamualaikum. My name Muhammad Shahir bin Sabri. Matric number B0121101163 from BEKG section 3. For this part, I want to discuss comparisons, similarities, and differences about the telephone network and the internet. For the comparison between telephone network and the internet, the telephone network will be able to connect to the internet network using a dial-up connection and dial-up modem, but the data rate will be very low. For the internet connection is made to the networking using a broadband modem, and hence the data rate will be very high. For telephone network, the billing is done based on the duration of call and the area of calling. For the internet billing will be mainly on the usage of the data in bit per second. Telephone network can only give one-to-one connection only using a dedicated channel in the network. For internet can have one-to-many connections through any channel which is free at the point time. Next, the similarities telephone network and the internet. They both use numbers as specific identifiers such as telephone numbers for different connection between two parties and IP address for connection between different website and computer. Next, the both are form of connection between two parties worldwide. The internet and telephone network are both switched network with circuit and packet switching. Both internet and telephone network are public network or network service provider. For lastly, both offer end-to-end data transmission. Next, the difference between telephone network and the internet. The network is defined as a group of two or more computer systems. For the internet is the interrelationship of a few networks only. Network for the coverage is limited comparison of the internet. The telephone network are only capable of transmitting a single bit of data at a time, whereas the internet is capable of multiple bits of data being transmitted at one time. Telephone network connection can only be established between two endpoints, the caller and the receiver. The internet not tied down to one connection but multiple connections, allowing the connection and bandwidth to share among many users at once. The internet is wireless, meaning can be anywhere in the world and pick up a connection, whereas a telephone network can only make connection in specific area, basically wherever there are phone lines present. That's all. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ashraf bin Karim Rizal. My number matrix is BE01211043. Today I will present about the answer for question 3. As we can see in this slide, for question 3, an internet service provider ISP is granted a block of address starting with 150.80.0.0/16. The ISP want to distribute the block to 2,600 customers as follows. The first group, 200 medium-sized business, each needs 128 address, and the second group has 400 small business, which needs 16 address, and the third group has 2,000 household, each needs 4 address. Design the subblock and give the slash notation for each subblock. Find out how many addresses are still available after this allocation. From this slide, this is calculation for first group. The first group has 200 medium-sized business and each needs 128 address. And the IP address given for this question is 150.80.0.0/16. And the subnet mask for first group is 255.255.255.128. And the number of valid hosts for subnets equal 2 power of 7 equal 128. After that, we convert the IP address and the subnet mask in a binary numbers. After that, by using the binary number of IP address and subnet mask, we calculate it by using logical and table, and the network of 150.80.0.0/1C is 150.80.0.0, and the subnet mask subnet IP address for first group is 150.80.0/25. 25 is the number of bits from subnet mask binary numbers, and host bit mask is the value of subnet mask we convert from 1 to 0 and 0 to H. After that, by using the binary numbers of IP address and host bit mask, we calculate it by first host bit, and the broadcast IP address for first group is 150.80.0.127. The first network for valid address range of host IP address is 150.80.0.0/25 until 150.80.0.127/25. And the second network for valid address range of host IP address is 150.80.0.128/25 until 150.80.0.255 until 25. We calculate it the same method until 200 network for valid address range of host IP address 150.80.99.128/25 until 150.80.99.255/25. And the next available address for this group of first group is 150.80.100.0, and we calculate 200 times by 128. The answer is 25,600 is available for address for first group. So 25,600 is available for address for the first group. For the second slide is the calculation for second group. We using the same methods for second group and third group. The same method with first group we calculate it, but the difference for second group is the second group has 400 small business and each needs 16 address, and the subnet for second group is 255.255.255.240, and the number of valid hosts for subnets equal to power of 4 equal 16. And after that, we using the same method, we convert the IP address and the subnet mask in a binary numbers. After that, by using the binary numbers from IP address and subnet mask, we calculate it by using the logical and table. And the result for the network address of 150.80.0.0/16 is 150.80.0.0, and the subnet IP address for second group is 150.80.0/28. And the value of host bit mask by using the subnet mask binary numbers, we convert 1 to 0 and 0 to H, and continue with the available address from first group is 150.80.100.0, and the broadcast IP address for second group is 150.80.115/28. 28 is the number of bit 1 from the subnet mask binary numbers. And the first network for valid address range of host IP address for second group is 150.80.100.0/28 until 150.80.100.15/28, and the second network for valid address range of host IP address for second group is 150.80.116/28 until 150.80.100.31/28. until the 400th network for valid address range of host IP address. The result is 150.80.124.240/28 until 150.80.124.255/28. And the next available address for second group is 150.80.125.0, and we calculate for hundreds times by 16 equal 6,400. So the 6,400 is the number of available for address in second group. For the third group, also using the same method with the first and second group, but the difference for third group has 2,000 households and each needs 4 address, and the IP address given also same with first and second group, 150.80.0.0/16. But the subnet mask for third group is 255.255.255.252, and the number of valid hosts for subnets for third group is 2 power of 2 equals to 4. And the next step, also using the same method, we convert the IP address and subnet mask in binary numbers. After that, by using the binary number of IP address and subnet mask, we calculate by using the logical AND table. And the network address of 150.80.0.0/16 is 150.80.0.0. And the subnet IP address for the third group is 150.80.0/30. 30 is number of bit ones in subnet mask in binary numbers. And the host bit mask, the result of host bit mask is we using the binary number of subnet mask, we convert from 1 to 0 and 0 to H. And we continue with the available address in the second group, 150.80.125.0, and the broadcast IP address for third group is 150.80.125.3/30, and the first network for valid address range of host IP address for third group is 150.80.125.0/30 until 150.80.125.3/30. And the second network for valid address range of host IP address 150.125.4/30 until 150.80.125.7/30. We calculate the same method until 400 networks for valid address range of host IP address is 150.80.156.60/30 until 150.80.156.60/30. And the next available address for third group is 150.80.157.0, and we calculate 2,000 times by 4 is 8,000, and the 8,000 is the numbers of available for address in third groups. Lastly, we conclude that in the first, second and third group, for the first group we calculate 200 times by 128 equal 25,600 is the numbers of available for address for first group, and the second group is 6,400 available for address in second group, and lastly in third group we have 8,000 available for address in third group. After we total the three groups, we total it 25,600 plus 6,400 plus 8,000. The result is 40,000 is available for address. Next, the total address for this question of question 3, the calculation is 2 power of 14 equal to 6,384 blocks in class B, and 16,384 blocks equal to 6,536 address in each block. By using for this data, we minus with 40,000 number of available for 3 group we total it before, and the result is 25,536. That's remaining address, and that's the number of available after this allocation. Thank you.